So the next set of examples in 1.2 is actually solving equations. And there's a little bit of information up at the top about the different types of equations. You will not be asked to identify any of those kinds of equations by name. So I'm going to let you read through that on your own, in your own time. And again, you won't be asked any of those by name, so not really something that you need to remember. But solving equations is also a very important part. I think it's one of the basic ideas of algebra is being able to solve something. So taking a look at something like example 2a, anytime you have parentheses like this, one of the easiest ways to do it, that means distribute, right? So we're going to distribute this in. So this is 6 minus 8z, and this is negative 10z minus 15 equals z minus 17. And there's lots of different ways to go about it from here. I do like to deal with everything on one side and then combine the sides first. So let's do that. So this guy goes with this guy. They're like terms. That's negative 18z. This guy goes with this guy. And 6 minus 15 is negative 9. So this is minus 9. And that now equals z minus 17. So now we're going to combine terms across. So I'm going to add the 18z to this side. So that's going to make this 19z. I'm going to add the 17 to the 9. And negative 9 plus 17 is going to be what? Negative 9 plus 17 is going to be 8. And then divide by the 19. So this is 8/19 equals z. So yes, your answer is a fraction, but that's still the answer and everything's okay. If you wanted to take the fraction and plug it back into your original problem with the calculator and check it out, it's probably a good idea, but I feel pretty confident that we're good to go. Same thing happens on letter B. So I'm going to distribute this in. So 8y squared minus 24 plus 8y squared minus 24 equals 16. Okay? So I can put the 8y with the 8y, that's 16y squared. Negative 24 with negative 24 is negative 48, and that equals 16. I'm going to add the 48, so 16y squared equals 64. Divide by the 16, so I get 64 over 16. 64 over 16. I could reduce it, but I'm not going to because I'm going to go ahead and take the square root, and these are both perfect squares, so I'm going to take the square root of both sides, and knowing that these are perfect squares, I can square root each piece because that's how you do square roots of fractions. So the square root of this fraction is the square root of the top and the square root of the bottom. The square root of the top is 8. The square root of the bottom is 4. And anytime you take the square root of something, remember you get plus or minus. So this is plus or minus 8/4, which is actually plus or minus 2. So y would be plus or minus 2 in that situation. Hopefully that's not an issue. Distribute, put things together, and then solve. Make sure when you take square roots, though, that's a big thing. When you take square roots, you get plus or minus, so make sure you're looking for that. In section 3, still section 2, example 3. So this section is something that people don't often talk about, but it's something that we really need to be able to do. There's two different ways to solve this equation when you're dealing with fractions, right? The easiest way to do this is to take care of the fraction before you even do the problem, okay? So here would be the example of what you would do to solve this one if you didn't get rid of the fraction. So in order to put these two together, you notice you're adding fractions. Remember, you have to have common denominators. So the common denominator between these two would be 12, right? So you would have to multiply this one's times 4. So you'd multiply the top by 4 and the bottom by 4. On this one, you'd multiply the top by 3 and the bottom by 3. And let's go ahead and make this denominator the same as well. So let's multiply the top by 6 and the bottom by 6. So when I do that, on the top I'm going to get 4t minus 4 over 12. I'm going to get 3t plus 15 over 12. And this is going to give me 6 over 12. Okay? So then, if we're combining things like you normally combine things where you're keeping the fractions, as we combine these things, I can add these guys together. So this would be 7t plus, 11 over 12 equals 6 over 12. To solve fractions like this, you would cross multiply. So this would be 7t plus 11 all times 12 would equal 6 times 12. If I divide the 12 out of both sides, that cancels out. So I have 7t plus 11 equals 6. So 7t should equal 6 minus 11, so negative 5. So t would be negative 5 over 7. So that would be your answer if you kept the fractions. But another way that you can do that is what they call clearing out the fractions, so you get rid of them. So if you notice that the common denominator of all of these is 12, then you can get rid of that at the very beginning, okay? And this is going to come in really handy when you have variables in the denominator or like really large numbers that you want to get rid of. So if I multiply this first fraction by 12, so I'm essentially putting a 12 on the top. The 12 over the 3 is going to reduce to 4. So I'm really multiplying the top of this by 4. So all I have left is 4t minus 4. Okay? I'm going to do the same thing with this second fraction. If I multiply this second fraction by 12, the 12 over the 4 is going to cancel out. That leaves me with 3. So this is really 3 times the top. So this is 3t plus 15. Okay? If I do the same thing with this one, I multiply it by 12, I now have 12 over 2, which is just 6. So we get to the step where I can combine like terms much quicker. Okay? So again, I took the 12, multiplied it times this, reduced the fraction, and then distributed that in. Multiply the 12 times this, reduced the fraction, multiplied that in. The 12 times this one, reduced the fraction, and got 6. Now I can just combine like terms. That's still 11. And I'm solving the function much quicker. Minus the 11 gives me negative 5. Divide by the 7 is negative 5/7. So I'll get the same answer. It just simplifies the first couple of steps into something much, much easier. And when you're dealing with large numbers, that's way helpful, okay?